Next on the bench, we got a DAC Mark 10 in for repairs. Got some meter lights. Yeah, he wants those replaced so they light up. Didn't have any power output. And that variable air gap capacitor right there is damaged. You just breathe on it and it'll spin. So I was going to try to repair that or replace it. If I replace it, I'm going to drill a hole back here and mount a variable air gap capacitor in the back so you can adjust that. That's the final output tune right there. The final output Pi network. Ooh, scary. I got it tuned up with Deadkin 2. It's swinging a little over 10. So that's where we're at on that project. This is not a restoration. It's just patch it up, you know, and do what you got to do to make it all right. So that's what we're going to do. Just do some basic repairs. Well, actually, that's not going to be that basic. Catch me later. Psychotech Labs signing off. Okay, so we were doing a little bit of work on the DAC last night. It's having some weird anomalies with the plate current. And then all of a sudden, it went pow, pop, 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 and then I got it shut off. Weird thing is, I was expecting to see a blown capacitor that really blew the hell up. There's no residue, no sign, nothing. So we're going to bring it up on the Variac and see what it does. Stay tuned. Isn't this exciting? Yeah. So weird. Oh, I see it. I see it. Right down there in that sideband switch. Yep. That's a weird place for it, huh? Okay, so we got to figure out why the sideband switch is sparking and arcing. That's some big arcing too. Oh man, I've worked on a lot of these DAC Mark 10s over the years, and I've learned to, you know, just accept the fact that you're going to go 2 steps forward and then bam, 1 step back. So yeah. Severe snapping in the sideband switch. Yeah, it's not good. Not where I expected it to be. Alright, we're going to go ahead and see if we can figure out what the hell's going on. Stay tuned, we'll be back. Okay. We're lower sideband. We've got that grounded to the case. We'll bring it up on the Variac. Keep it sparks and arcs. So far so good. Kind of broken wire. It might have been shorting out. Maybe, I don't know. So far so good. Turn it up on AM. I hear something. Thought I heard a little sizzling. No snapping though. Upper side. There it goes. Come on, do it when I'm watching. Okay, let's see the area. I don't know why. Shouldn't even. Why the hell are they running that kind of high voltage through that switch? Like that switch is fucked. That's fucked. That switch is going to be a bitch to replace. First you get to find one and everything else. Fuck me. I don't know, man. Yep. When I seen this, I should have ran instead of say, yeah, I'll take a look at it. I was just supposed to do some basic spot repairs on it, get it ready to sell, you know, put some meter lights in it, figure out why it wasn't really putting out any power, which we did. We got that all fixed. Had it all set up. All we needed to do was the meter lights, and then this switch started doing this. I don't know, man. I don't know. Catch me later. Okay. So, this wire right here hooks over to the high voltage over here. I'm going to cut that wire. I don't have schematics that show this section or the tube section. So, probably I don't have to go borrow some. I don't know any reason to run high voltage to the sideband switch. Absolutely no reason at all. So, since we don't have the Samsonite fact handy, we're going to cut this wire, bring it up on the Variac, and see what happens. So, wish me luck. Okay, just like I thought, because there's no way the high voltage is going to have anything to do with the receive. So, yeah, with that wire cut, I'm no longer sparking and arcing here, and I'm not transmitting. This has a tube final. The high voltage is used in this radius. It's mainly solid state, but the high voltage section, it just runs two tubes, a driver and a final. We're going to go look up the pinout on this tube on the final, and we're going to see if we have high voltage going to the tube, and I'm betting we don't, which means I can go from there to the tube, bypassing that high voltage going to this switch, just for testing purposes. If it transmits, we're going to go ahead and do some tricky stuff. Catch me later. Alright, right there, burnt resistor. I was keying it up. That was glowing. So yeah, we gotta replace that resistor right there. Oh boy. Well, let's get to it. Okay, making progress. Ooh, look, we got the handles back on. Okay, so we replaced that resistor that was in there with another resistor. We are no longer snapping and crackling and popping in the sideband switch. Apparently that resistor, because it was kind of burnt to where it wasn't making a connection, apparently it was making a connection and breaking the connection. So it was opening and closing, kind of like a set of points in a car, which was causing the little lightning bolts. Because you shouldn't arc an arc gap that far. That's normally what you'd see a car coil do. Audio. Hello. So we're doing about 3 watts. Hello. Pegging a 10 watt scale. So that's about where we're at right now. Making progress. It's coming to life. We got to replace 2 more capacitors. That low voltage cap there is swelled up, and then we got to replace the other leg of this cap with a capacitor. So replace those 2 caps and call this thing good. A little bit more than some spot repairs. Looks pretty with all the meters lit up, huh? We use these little LED lights that are made for this application. What comes out of the meter is these little things here. They're basically little bulbs, especially made to go in the meters like that. Alright, catch me later. Okay, there it is, all done. So replace the high voltage caps, the main low voltage cap. Had to replace a resistor and do a bunch of troubleshooting. This thing's been wired for a standard 4-pin Cobra mic, and hello. Audio. It's about 3 audio. Let's swing to about 16, 17. So there we go. Another DAC Mark 10 done. Hey, thanks for watching my videos, everyone. Psychotech Labs signing off.